The life-creating element was discovered some 12.88 billion light-years away in a pair of merging galaxies collectively known as SPT 0311-58. Using the powerful Atacama Large Millimeter, Submillimeter Array ALMA, in Chile, researchers at the University of Illinois detected evidence of water H2O, and carbon monoxide CO. The two elements are the key building blocks of life, as far as we know it, and their presence in a galaxy nearly 13 billion years ago indicates the molecular universe got going on very early on, within 780 million years of its birth. Srivani Jaragula, principal investigator and an astronomer at the University of Illinois, said, using high-resolution ALMA observations of molecular gas in the pair of galaxies known collectively as SPT 0311-58, we detected both water and carbon monoxide molecules in the larger of the two galaxies. Oxygen and carbon, in particular, are first-generation elements, and in the molecular forms of carbon monoxide and water, they are critical to life as we know it. This galaxy is the most massive galaxy currently known at high redshift, or the time when the universe was still very young. It has more gas and dust compared to other galaxies in the early universe, which gives us plenty of potential opportunities to observe abundant molecules and to better understand how these life-creating elements impacted the development of the early universe. The study's incredible findings were published in the Astrophysical Journal. SPT 0311-58 is comprised of two galaxies that were first detected by ALMA in 2017. It was dated to the so-called epoch of Ryanization when the universe was only about 780 million years old, about 5% of its present age, when the first stars and galaxies were being born. Astronomers strongly suspect the two galaxies are merging into one unit but may eventually evolve into two separate, massive elliptical galaxies. Water is the third most abundant molecule in the universe, trailing just behind hydrogen and carbon monoxide. Previous studies of the local and early universe have found a correlation between water emission and the far-infrared emission from dust. The local universe describes a region of space that spans roughly 1 billion light-years in radius, in which galaxies are pretty much frozen in their present-day state. The early universe, on the other hand, marks the vast expanse of the universe from which the light reaching Earth exposes the earliest days after the Big Bang nearly 14 billion years ago.